Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics N4. So in this platform actually we shall be working on the question paper which was written in November 2018 for mathematics N4, which is an X paper. So we shall quickly rush through the question and see what we were given. So if you are new guys, you can consider subscribing to this channel so that you won't miss any of the classes that we shall be having for Mason African Motives. So here we are given the instructions and the information and to answer all questions, and also the most important part, that the degree of accuracy should be given to 3 decimal places unless indicated otherwise, and also everything that is there should be very clear. Whatever that you're going to do, you must make sure that you write in a clear way. All right, so that's what we had guys, and that's our first question, which is on integration. That is integrate the following in terms of x, and that is 7 marks for that. So this type of a question, you have to integrate each and every term that you're given there. So this is what we had here, which is something like this. I don't know if it is going to be clear. All right, let me just put it aside here. So what we are going to do is to simplify this part first. 1 over square root of 2x, we just put it aside and so forth. So this is going to give us something like this. We know 1 over square root of 2x is going to give us 2x to the exponent of what? Of negative half from the square root, because it will be like this. 1 over 2x to the exponent of a half, like this. Then when you write it on top, it is going to have a negative like that, which means this actually means 2 to the exponent of negative half by x to the exponent of a negative half. Remember, from your laws of exponents, you're going to multiply these two like that. So that is what you're going to integrate. All right, so we have got 2 to the exponent of minus half multiplied by, if we integrate this, remember we add 1 to the exponent, which is going to give us x to the exponent of a half, if I'm not mistaken there. That's a half over a half, like this, of which if you are to cross check here, it's like we're having a negative exponent here. All right, so, and also this is 1 divided by this one. It's 1 divided by a half. So if you divide from your calculator like this, 1 divided by a half, that's going to give you a 2. So which means we have got a 2 here on top. So you've got 2 to the exponent of negative half by 2 by x to the exponent of a half, like this. This is what we have. And remember, this is a negative, so you can write it in the denominator again. So it's going to be 1 over. So you're going to be left with these 2 because they are not carrying any negative. So you're going to be left with 2x to the exponent of a half, like this, over 2 to the exponent of a half. But we all know that to the exponent of a half simply means square root, just like what we had here. That was a square root. So this is going to give us 2 square root of x over this is 2 to the exponent of a half, which is square root of 2. So this is what we are going to have, 2 square root of x over square root of 2. So integration, guys, is all about the way that you're going to do it. You must try by all means to simplify each and every part that you're given in its simplest form, so that you'll be able to integrate. So once you're at this stage, you can integrate. Once you're at this stage here, you can integrate. So you can separate first, then you can integrate. All right, so then the other part, we have got e to the exponent of negative 10x, that is 2, sorry, to the exponent of negative 10x, like this. So remember the integral of e of a, that is, let me just show you from your formula sheet. Maybe some of you need to know this from the formula sheet. Here you'll be given the integral of k a to the exponent of x, which is kx to the exponent over ln a. So but if you have got here, there's 10x here, so this is not clear. Here you are going to find the derivative. Okay, if it is like this, if maybe it's k a to the exponent of f of x like this, this is going to give you the integral of this is going to give you k a to the exponent of f of x like this over the first derivative of f of x ln a like that. So this is what you're going to have. So that means this part is going to remain as it is, which is 2 to the exponent of negative 10x. Then now here, as you can see, this is the derivative of f of x there, the first derivative of f of x, which is the first derivative here. This is minus 10x, so you're going to obtain minus 10 ln a, which is our a in this case, is 2, so it's going to be ln 2 like that. So that's what you're going to have, of which you can just write this negative on top like this, negative 2 e to the exponent of negative 10x over 10 ln 2. You can just write your negative on top. Remember, just like 1 over minus 2, this can be written as minus 1 over 2. It's one and the same thing. So that means from this part here of 2, whatever that we had here, we are going to obtain that part, which is negative 2 to the exponent of negative 10x over 10 ln 2. So this is what you're going to have there. All right, so you move on to this part of e. We find the derivative of e, and remember e applies the same thing with a2, so it's going to be e to the exponent of kx like this, that is over 2. So remember, e applies the same thing just like what we did here. So we are going to have something like this, e to the exponent of minus kx like that. Remember, we are going to, there was already a 2, this one which was there, so you're going to write it as it is. Then you find the derivative of what, of k here, which of x, which is going to give us minus k. The derivative of minus kx, we are going to take minus k, so it's going to be minus k ln e, which is this one, just like ln 2, so it's going to be ln e, but we know that ln e is equivalent to what, to 1, so this is going to give us a 1. So it's going to be 2 times minus k, which is minus 2k, of which I told you you can write the negative on top. So it's minus e to the exponent of minus kx over 2 times k, which is 2k, because it was minus 2k, so you wrote the negative on top, so it's going to be positive. And we said ln e, it's 1, so it can be just 2k like that. All right, so that is what you're obtaining from e. So it's going to be minus this part that we obtained here, which is e to the exponent of minus kx over it's what, 2k over 2k, yeah, that's 2k. All right, over 2k. So the 2, remember, it's from the denominator which was already there. All right, so that's what you're going to have there. We move on to this one, minus 4 pi whatever that you're going to have there. So we have got the integral of 4 pi x squared dx like this. So remember, this is with respect to x, so we are just going to add 1 here, which is 4 pi x to the exponent of 3 over 3. We are, because here there's nothing that is going to affect. Okay, so it's going to be, but there was a minus there, so it's going to be minus 4 pi x to the exponent of 3 over 3. So yes, direct. Same here with cos. Remember, cos gives us sine from the integral. Cos gives us sine here from the integral here. Cos gives you sine, but if it is like this, cos ax like this, it is going to give you 1 over a sine ax, which is the same like sine ax over a like that. That is what you're going to have. So here, this is 2 pi cos omega. This is omega like this, that omega. So our answer is going to be plus 2 pi Remember we said this cos is going to change to sine, so it's going to be sine omega x everything over omega there. All right, so you're going to divide by that w, which is omega, which is the same thing with cos x squared there. So cos x squared, I want you to check here, we do not have like the integrals here, but you're going to remember integration is the reverse of derivative. So if you integrate this, you are going to obtain this. So because when you find the derivative of cot, it gives you minus cos x squared. So the integral of minus cos x squared is going to give us cot x. But remember, there is a number which is affecting here, which is this 5. So just like what we did here, to divide by 5, that is what is going to happen. So it is going to look like this. It is going to be 5 cot 5x over 5 like this. We divide by this 5, this is going to cancel like that, so it's going to be cot x, cot 5x. All right, seems like we are done. Then plus the constant of what? Of integration. That's what you're going to have. So that's the idea there. That's the idea. So as you can see, guys, that whenever you are working with integration, you have to separate each and every part in a way that you'll be able to integrate. Then you just write, so that's 1 2 3 4 5 6 7. That's 7 marks for you. So don't forget to write the constant of what? Of integration there. So that's what we had on this question. As you can see, it was a little bit direct or a little bit straightforward there. So the other part is to evaluate the integral of whatever that you're given there, and it's 4 marks. So this is like this. We have got the integral of, we are given the limits 0 to pi over 2, and this is sine 2x dx like that. All right, so this is what we are given, guys. We are given the integral, and remember the integral of sine from your formula sheet is going to give you minus cos. But remember, when there is an a like this, is going to be 1 over a, or whatever that you have over a. So since this is minus cos, all right, so this is minus cos, so we are going to have minus cos 2x over this 2 over 2 like that. That is the integral. So that's the integral. Then you put in your limits, which is pi over 2 0. The plus c does not matter when you've got limits like that. There's no need for you to write that plus. Yes, you can write it, but there's no need there. So you can just substitute your values and make sure that your calculator here is in radians. So it's going to be minus cos, this is 2x like this, which is 2 times pi over 2 like this. As you can see, it's going to give us pi. So it's going to be minus cos pi over 2 minus, okay, we subtract the bracket, which is minus cos, we substitute here 2 times x, which is 0 here, 2 times 0, that's 0 over 2. All right, so use your calculator to simplify. Here we are going to obtain a positive half, minus here we are going to obtain a negative half from this, and make sure that your calculator is in radians. All right, so this is going to give us a 1 at the end. If you add properly there, that's a 1. So that's it, guys. As you can see, just direct like that, integrate, then put in your values and so forth. That's it. Then the other part, we are given to draw the graph of y is equal to 2 to the exponent of x, and we have limits x to 1 and x to 4. All right, so this part, what you just need is to know the type of a function that you are working with. Remember, this follows the same thing as the graph of y is equal to e to the exponent of x, which passes through the y coordinate at 1 like this. So it's the same thing with 2 to the exponent of x. All right, so it's going to look the same way. We are going to have it the same way. All right, so that's here 0, so it looks like this. So it turns as if it approaches to the x-axis, but it's not going to reach the x-axis. Then it goes up and up and up and up and up like that. So this point here only occurs when x is equal to 0, which is 2 to the exponent of 0, which is 1. So this point here, that's a 1 there. All right, I'm looking for something here. All right, so this point here, That's a 1 here. So this is y is equal to 2 to the exponent of x. All right. So that's the only point that we can have on this graph, but we are given further on some boundaries to use here. We are given further on the area that you are going to have is between the graph, the x-axis, the line x is equal to 1 and x is equal to 4. So this is your x-axis. The line x is equal to 1 and x is equal to 4. So x is equal to 1. This is a line which is a vertical line which passes through the point 1, and x is equal to 4 is the same thing. It's a vertical line which passes through the point where x is equal to 4. So this is 1 here and this is 4. So that's what we have. So these are the lines that we have. X is equal to 1 and x is equal to 4. So that means the area that we are talking about is the area that is in between here, this region here, because we need something that is enclosed, that is covered by this graph, this line and the x-axis. So this is the area that we are talking about. So what you do is that you draw the representative. So as you can see, the representative strip is limited for x, 1 and 4. So these are the values for x. So your strip is going to be for x-axis like this. So this is going to be your representative strip. All right, so that is what we had there on 1.31, that you just need to indicate the area enclosed by that graph. Then on 1.3, to determine now using integration the value of the area, that is the area enclosed now. So remember, area is just the integral. That is area, guys. The first thing on the applications of integration is to calculate area. That is the first application that you are supposed to know, guys, in mathematics, that area is equal to the integral of y with respect to x with the limits a and b, where this y is the bounded part of the graph here, and a and b are the limits. So this is your a and this is your b, and our y is this one, which is 2 to the exponent of x. So we are going to have it as we said, our limits is a and b, which is 1 and 4, the lower value and the maximum value 1 and 4, 2 to the exponent of x dx, because this is your y, which is 2 to the exponent of x. So what you need is to integrate. All right, we have to integrate. So that's put in your values and integrate there. Remember, 2 to the exponent of x, we talked about this one before. So it's going to give us 2 to the exponent of x over the derivative of x, which is 1. So it's going to be 1 ln 2, this one. So 1 ln 2 is the same as ln 2, guys, and you've got your limits 4 and 1. So there's no need of you writing plus c if you're given limits like this, guys. All right, don't worry about that. So ax is going to be, substitute here in place of x, you substitute 4, so it's 2 to the exponent of 4 over 1 ln 2. This one is just same like this, guys. 1x is same as x, so 1 ln 2 is same as ln 2. All right, minus, so this is your upper value, minus the lower value, which is 1. So you substitute 1 here, which is 2 to the exponent of 1 over ln 2, of which 2 to the exponent of 1 is same as 2. So all you need is to use your calculator to simplify, guys, this direct, which is going to give you something like 20,1977305, something like that, which is 20,198 to 3 decimal places is going to give us 8, and this is area, which is measured in square units. So area, that's square units. So that's what we had, guys. Just like that, area, integral, the integral, that is your area. Okay, then determine using integrate, that is what we had, and they are simplify. So this one is just to simplify, just to integrate. So all you need is to know the laws that you're going to use there. Remember, and this one we have been talking about this. If you cross check, guys, most of the questions we have been talking about this type of a question. So we said when it is like this, this part is going to remain as it is, which is 4e to the exponent of minus x over the derivative of x here, which is minus 1. So we've got minus x, which is going to give us minus 1, ln e, which is your a in this case is e, so it's ln e, all right, minus, we do the same here, 11 to the exponent of 3x over the first derivative here of x, which is 3, ln a, which is our a in this case is 11, plus the constant of integration, all right. So remember we said ln e is equal to 1. So if ln e is equal to 1, that means here we've got minus 1 times 1, which is minus 1. So 4 divided by minus 1 is minus 4. So this is going to give us minus 4 e to the exponent of minus x minus, here there's nothing that we can do, 11 to the exponent of 3x over 3 ln 11 plus c. So there, as you can see, there's nothing that you can do there. Is there anything that you can do? No, there's nothing that we can do. All right, so that means we are done. We've got our 3 marks there, just like that. And as you can see, it's easy to get 20 marks, guys, on integration. As you can see, it's very, very easy to take all those marks on integration. All right, anyways, let's see another part that you're given on 2.1 to expand to 4 terms only by the use of the binomial theorem. Okay, remember the binomial theorem, guys, and this is one of the most important part that you're supposed to know, because they're going to ask you a question on that type of a application. So here we've got the square root of 16t squared plus 4. So remember our binomial theorem, guys, actually, okay, let me just write it this way. Maybe it can work properly. So I'm gonna rewrite this. Remember, square root means to the exponent of a half, but if it is 1 over, so it's going to be to the exponent of minus half. So this part here is going to be everything here, 16, this is t squared, guys, all right. So this is 16t squared plus 4 like this to the exponent of negative half, all right. So remember our binomial theorem that if you are given something like x plus h to the exponent of n, we are going to have x to the exponent of n plus n, x to the exponent of n minus 1 h plus n by n minus 1, x to the exponent of n minus 2 h squared, something like that, 2 factorial plus, and so on and so on and so on. So that is what you're going to have. That is here is simply the first part you raise to the exponent as it is, then you drop the exponent and subtract 1 and so forth. So I'm going to explain this part here as we are going to have it. Okay, so what I mean is that this is going to give us, this is your x, as you can see, this is your x, this is your h, all right. So this is your x, everything here, and this is your h, all right. So you said x to the exponent of n, this is our n, which is the exponent, all right. So it's going to give us x to the exponent of n, which is 16t squared. This is our x to the exponent of n, which is minus half, like that, all right. We move on, plus n, which means here we have to drop this exponent, which is n, then we have to subtract 1 on the exponent. So it's going to be plus, which means this stage we multiply by negative 1, negative half in this case. So it's going to be plus, we drop the exponent, which is negative half, like this, all right. Then what happened, we subtracted 1 on the exponent, so it's going to be like this, 16t squared, like this. Then if we subtract 1 on minus half, like this, minus half minus 1 is going to give us minus 3 over 2. So we are going to obtain minus 3 over 2 there, all right. So this is going to give us to the exponent of minus 3 over 2. Then here our h starts to operate now, which is our h in this case is 4. So 4 now starts to operate, so it's going to be times 4, like that, all right. Another stage, plus, we have to drop again this exponent, which is minus 3 over 2. So it's going to be minus 3 over 2 again, just like what we did to minus half. So you drop this exponent, so there is minus half this time. So it's going to be minus half, which was already there, times, so let's just put this in a bracket maybe, minus 3 over 2. You drop that minus 3 over 2 just like what we did. So it's going to be minus 3 over 2 like that. Then we subtract 1 on the x, just like what we did when you drop this minus half, we subtracted minus 1. So it's now minus 3 over 2 minus 1, which is minus 5 over 2. So that's the concept here. So you subtract minus 1. All right. So it's going to be x, which is your x, this one. So it's going to be 16 t squared, which is our x, to the exponent of minus 5 over 2. Okay. Then this 4, what is going to happen? This is now h squared, which is 4 squared over 2 factorial. So our h is 4. So it's going to be 4 squared like this. Everything over 2 factorial like this. So this was supposed to be 1 factorial, of which 1, guys, there's no need of you writing this 1 factorial. Okay. So how many terms do we have now? We have got 1, 2, 3. We need another term, the fourth one, which is the fourth term. We do the same again. We drop this exponent. So that is the pattern. You drop the exponent, subtract 1, drop the exponent, subtract 1 like that. So you're going to drop the exponent, which is you multiply to these ones which are already there. So it's minus half times minus 3 over 2 times. So if we drop this exponent, it's minus 5 over 2. So it's minus 5 over 2 like this. All right. Then we subtract 1. The moment you drop the exponent, subtract 1. So it's going to be 16 t squared to the exponent of, if we subtract 1, it's going to be minus 7 over 2. Then this 4, we increase 1 here. As you can see, it was 1 here, now 2. So now it's going to be 3. So it will be to the exponent of 3 over 3 factorial, just like that. So that is the pattern. So this pattern is going to go and so on and so on and so on and so on. Okay. So now we have to simplify further and see what you're going to have. So maybe you can have some time that you're going to talk about this as a separate topic, so that maybe we can actually understand what's that binomial theorem is all about. But that is the idea there. So what you do is that you have to simplify here. So you're going to raise from your calculator 16 to the exponent of minus half, because this is affected. So it's 16 to the exponent of minus half from your calculator like this. So it is going to give you 1 over 4. All right. So here we are going to obtain, okay, let me just write it in, right? So it's going to be 1 over 4 like this. Then the exponent, you multiply the exponent here, that's 2 and minus 1. So 2 times minus half, sorry, which is minus 1. So remember from your laws of exponents, guys, an exponent and an exponent, they multiply each other. So that is what is happening here. 2 and minus half, that is minus 1. So it's t to the exponent of minus 1. All right. At this stage, I want you to see what you're going to do from your calculator. You are going to write, this is what you're going to write on your calculator. Half, this one, minus half, this one, times 16 to the exponent, because there's an exponent here. So you're going to raise this exponent 16 to the exponent of minus 3 over 2 like this. On your calculator, this is what you're supposed, this is how your calculator is supposed to display like this. Minus half, this one. All right. Minus half like this. Okay. Times 16 to the exponent of minus 3 over 2. So it's times 16 to the exponent of minus 3 over 2 like this. We are done with this 16. There is a 4 which is there also, this one. So you multiply by 4. So it's times 4. This is what you're supposed to write on your calculator, times 4 like this. All right. Then everything over 1 factorial, of which 1 factorial is same as 1. So there's no effect here. Over 1 factorial does not affect. So this part alone, this one, is going to give you minus 1 over 32. If you do it properly, that's going to be minus 1 over 32. All right. Then here we are back to the, for t here, because this is t t cannot be simplified from your calculator. That is why we left it. You are going to simplify on its own. So it's t to the exponent of 2 times, because here there's an exponent. So you multiply 2 times minus 3 over 2, which is going to give us minus 3. So it's going to be t to the exponent of minus 3, just like that. So this is how you simplify it, guys. So you do that, and so on and so on and so on. So here you're going to do this minus half times minus 3 over 2 times 16 to the exponent of minus 5. So let me just write it: minus half times minus 3 over 2 times 16 to the exponent, because it's inside the bracket, so it's 16 to the exponent of minus 5 over 2, like this. This is what your calculator is supposed to be like. Over the whatever that you get, you divide by 2 factorial. So 2 factorial, it's shift. This is your 2 factorial here. So it's just shift like that. So this is the reason why I'm not using my calculator direct, because there's too much light here. So it's shift here like this. That is your 2 factorial. So it's just like 2. All right. So that is what your calculator is supposed to represent this as. It is like this. Then there's also this 4 squared. Take note, there's this 4 squared, which is, we left this one, which is outside also. So it's times 4 squared like that. So make sure you put everything so like this. So your calculator is going to give you 3 over 512. Yeah, positive 3 over 512 like this. All right, you move on to this part for t. So it's again 2 times minus 5 over 2, which is going to give you minus 5, just like what we did here. So it's going to be t to the exponent of minus 5. Then the last part, you do the same again, just like what we did. So this time is going to be minus half times minus 3 over 2 times minus 5 over 2 times 16 to the exponent of minus 7 over 2 times 4 to the, so your calculator, what your calculator is supposed to display is this. We said minus half times minus 3 over 2 times minus 5 over 2. So it's minus 3 over 2 times minus 5 over 2 times 16 to the exponent of minus 7 over 2 times 16 to the exponent of minus 7 over 2 times, there is this 4 which is outside this one. So it's 4 to the exponent of 3 over 3 factorial. Like this is what your calculator is supposed to look like. So when you do that from your calculator, you're going to obtain 5 over 4096. All right, t to the exponent of. All right, we move on to t. So this is t to the exponent of 2 and minus 7. So you do remember what you do, multiply. So it's 2 times minus 7 over 2, which is going to give us minus 7 like that. All right. So take note, our calculators, they give us values which are simplified like this. So you have to write them as they are from your calculator. All right. So remember to the exponent of minus means 1 over. So you're going to write this as 1 over 4t. So this is going to be equal to, so everything is going to be equal to 1 over, we say this one is going to be written down here, which is 4t. So it's 1 over 4t. We move on to minus 1 over 32. If we write this t down, it's going to be t to the exponent of 3. So it's minus 1 over 32 t to the exponent of 3. We move on to this one. We remove this negative again, write it down here. So it's going to be plus 3 over 512 t to the exponent of 5. You move on to this 7. You do the same, 5 over 4096 t to the exponent of 7. So this is what you're going to have, guys, for expanded value in a simplified manner, using simplified values. That is what you're going to have from your calculator. You simplify what your calculator can simplify. The rest you have to adjust the calculations by yourself. So that is what we had, guys. Let's see another question. which is to differentiate the following in terms of x. So whenever you are applying the derivative, guys, all you need to do is to make sure that you expand, just like what we did the previous part, expand each and every term so that you'll be able to differentiate. So here there's a need for us to separate here. So how can we separate these, guys? Remember, x over a over 2 like this is the same as x over 2 plus a over 2. So you can actually separate them with one denominator. So we are going to separate every term here. So it's going to be 5 over minus x. So it's going to be 5 over minus cos x. Okay, we separate 6x over minus cos x. Everything we separate. So it's going to be plus 6 sine x over minus cos x. Okay, x cos x over minus cos x plus x cos x over minus cos x, like this. So we had to separate each and every term there, guys. So if we separate them, what are we going to have? What do we have? Remember, this is the only part that we are working with here, the first part. So remember that 1 over cos is sec. So this is going to give us from 1 over cos, this one. This is your 1 over cos, this one, which is going to give you sec x. But you're going to be left with 5 divided by minus 1. So 5 divided by minus 1 is what? It's minus 5. So you're going to have minus 5 sec. Take note, we haven't started to differentiate. We are just rewriting. So we are going to have minus 5 sec x. All right, so we move on to another one. Here, what can we do? Remember that, guys, sine over cos gives us tan. All right, sine over cos gives us tan. But we are left with 6 divided by minus 1, which is minus 6. So you're going to have minus 6 tan x. So this is what you're going to have, like that. All right. Then we move on here. Cos and cos can cancel, which means you're going to be left with x divided by minus 1, which is minus x. So like I said, we are just rewriting. All right, this one, there's no need for us to do it. We just rewrite as it is. Remember, guys, log x in base e, in fact, in base e means ln. So this is going to give us minus 2 ln x, like that. All right, so now we can find our divide x. So remember, the derivative of sec gives us sec tan. Yeah, sec x gives us sec tan. So it's going to be minus 5 sec x tan x. Okay, then the derivative of tan is sec squared. So tan is sec squared. So we are going to have minus 6 sec squared x. All right, then we know that the derivative of x is 1. So it's going to be minus 1. E, this is a constant. E is just like a number, just like 2, just like 3, just like 4. And remember, the derivative of a constant gives us a 0 there. All right. Then ln, remember the derivative of ln, it gives us k over x, which is a k, in this case is minus 2. So it's minus 2 over x. That's k over x. So that's what you're going to have at the end. As you can see, yes, you can choose to simplify minus 1 plus 0, which is minus 1, or you can just leave it like that. There's no effect. So you can just choose to leave it like that. That's it, guys. So as you can see, these questions, they will be pretty much direct to the question, and so forth and so forth and so forth. Determine with the aid of differentiation on question 2.3 the coordinates of the maximum and minimum turning points of this curve. Also distinguish between the maximum and minimum turning points by the use of second derivative. All right, remember how you determine the maximum turning point, guys, that at any maximum turning point, the first derivative should be equal to 0. So that is the concept there, that is at any turning point divide x is equal to 0. Then we shall talk about how to distinguish them later on, but that is what we have here. So let's find our divide x, which is going to be, remember we dropped the exponent, which is 3x, then we subtract 1, which is 3x squared, and here it's going to be minus 2. and this is a constant, which is a 0 there. So this is our divide x, which is supposed to be equal to 0. So therefore 3x squared minus 2x minus 2 is equal to 0, like that. So we are ready to solve for x. How can we solve for x? Just transpose to the right hand side. Minus 2 is going to be positive 2 divided by 3 by 3. So x squared is equal to 2 over 3. So how can I find x if this is x squared? You have to find the square root, and take note that square root of any number is a plus or minus. So we're going to obtain two possible values of x from the square root of 2 over 3, which gives us a decimal, which is 0.81649, something like that, which is actually the first point is going to be x1, which is 0.816, which is a plus, or another one which is a minus 0.816, something like that. So these are the values of x that we are having at turning points. So which means we have to find now the corresponding value of y from the given function, which is y is equal to x cubed minus 2x minus 4. So we have to substitute the values of x that we are obtaining so that we can find the values of y to make it a point. Remember, this is a point, guys. Okay, so y1 is going to be, we substitute here in place of x, so it's gonna be 0.816 to the exponent of 3 minus 2 into 0.816 minus 4, like that. So your y there is going to be something like minus 5 comma something like that, minus 5 comma 0.866, 0.8866, yeah, something like that, which is a negative 5,089 to 3 decimal places. So that means we have got the first turning point here. So our first turning point, it's when x is this, y is this. Remember, it's a point made of x and y, like that. So x 0.816, and when y is minus 5,089. So that's our first turning point. We do not know that it's a maximum or it's a minimum. We just know that it's a turning point. All right. Then we do the same here. We find y2 so that we can find the second turning point when x is minus 0.81, whatever that you are going to have, which is minus 0.816 cubed minus 2 into 0.816 minus 4. So that's y2 there, which is going to give you minus 2,91133, which is negative 2,9113 decimal places as our y2 there. So therefore we are having the second turning point here, which is when x is minus 0.816, our y is going to be minus 2,911, like that. All right. So how is this going to help us here? Because we said at any turning point divide x is equal to 0. So we have our turning points here. The turning points are there. But the question is now we have to distinguish between maximum and minimum by use of second derivatives. So how does the second derivative affect in finding the maximum and minimum turning points? Okay, this is it. For the second derivative, when it is being determined, when it is greater than 0 like this, it means that point is a minimum turning point. But when our second derivative with respect to x is less than 0 like this, it means that point is a maximum turning point. That is how you apply your second derivative. So all you need is to continue from the first derivative that we had here. Remember, this was our first derivative divide x, which was 3x squared minus 2. So that is where we are going to continue from. All right. Our dy dx was equivalent to 3x squared minus 2. So the second derivative is just a continuation, which means we have to differentiate again this, which is going to give us minus 6x plus 0, which is a 0 there. So this is your second derivative, guys. So we are saying that From this second derivative that we are having, we are going to work with the first point. Okay, from the first turning point, our x was equivalent to 0. This is 0,816. All right, so we are saying for this value that we are having, that this value that we have here, what are we going to have for the second derivative with this value that we are having? Remember, our second derivative is 6x. So if we substitute that x that we are having, which is 0,816, what are we going to have? So in this case, we are going to obtain something like 4,816. This is our second derivative, guys. And this value here, let us compare between these two conditions. How can we compare this? Is it less than 0 or it's greater than 0? So as you can see, guys, this value here is greater than 0. 4,816 is bigger than 0. This one is bigger than 0, guys. So if it is bigger than 0 like this, it means that is a minimum turning point. So therefore, we are saying that the first turning point, which is 0,816, it was 0,816 minus 5 whatever that we have. Now we have to write the point that we are saying it's a minimum, that we are saying it's a, this which is minus 5,089. 89 like this is a minimum turning point. That is what we have from this part, because we said when it is greater than 0, that is a minimum. So that means the first turning point is a minimum turning point. So using the same thing, we apply this TP2. We go on to the second turning point. Remember, x there was negative 0,816. So you just do the same. You substitute into 6x, which is 6 times negative 0,816. So as you can see, we are going to obtain the same value with that one, but it's going to be a negative. And this value here is actually less than 0. And we said when the second derivative is less than 0 like this, it means it's a maximum turning point. So therefore, the second turning point, which was when x is minus 0,816 and the value of y was minus 2,911, something like that, this one is a maximum turning point. So that one is a maximum turning point and this one is a minimum turning point. So that's how you differentiate between two turning points to say this is a maximum turning point and this is a minimum turning point. That's how you simply differentiate between the two. So that's what we had in this case. And another part now is to differentiate the following by using the quotient rule. Okay, there we are being told to use the quotient rule. Okay, why are they saying so? Because actually, if we are to cross check, this was going to give us a straight 0 there. If we had to simplify whatever that we had, this one was going to give us a 0. I want you to see something here. If we had to simplify, this was just going to give us something like ln x to the exponent of 3 over ln x like this, which was going to give us 3 ln x from, remember, from our laws of logarithms, which is 3 ln x over ln x. So if you cancel ln x and ln x, this is going to give you 3, and dy dx is going to give us a 0, because this is y is equal to 3, so y dy dx is going to give us a 0. So this is what we are supposed to prove now using quotient rule. So you're supposed to prove this using the quotient rule. So how are we going to apply the quotient rule there? All right, this is it, guys. Your quotient rule, you're actually given the formula here. This formula, when the two are dividing like this, this is your formula for dy dx. All right, so that's what you're going to use there. So remember, we said we are given y is equal to ln x to the exponent of 3 over ln x. So there they want us to actually apply our quotient rule direct like that. Okay, so we are just going to put this, since we know our formula, there is a need for us to find the first derivative here. Okay, so how are we going to find the derivative? Remember, we said this is same as 3 ln x, so the derivative is going to give us 3 over x. All right, so this is 3 over x. We do the same here. This is our vx, which is equivalent to ln x. So what is the first derivative with respect to x, which is going to be 1 over x. All right, now we can apply the formula. Remember, our formula is stating that dy dx is equivalent to vx. Guys, I'm not going to write this down, I'm just going to substitute. Okay, this is vx, then the first derivative of what? Of u. So vx, in this case our vx is what? It's ln x, so it's going to be ln x times the first derivative of u, which is the first derivative of u, which is 3 over x. So it's 3 over x like this, minus, this time it's ux here, which is ux, then the first derivative of v. So ux, which is this one, which is ln x to the exponent of 3 times the first derivative, which is 1 over x of v, everything over v squared. So take note, this is vx squared. So everything is going to be over vx, of which our vx in this case is ln x. So it's going to be ln x like this, squared everything. All right, so that's what you're going to have. Is it going to be clear here, or let us just write it here? So our dy dx is going to be ln x times 3 over 2. This one, 3 over x is just the same as 3 over x ln x like that. Okay, then this is minus 1 times 1 over x, which is just same as minus 1 over x ln x to the exponent of 3 like that, everything over ln x squared, which can be written as ln squared x. Okay, so this actually approximates to 0 like that. Okay, if you simplify this, you're going to see that it's going to give you a 0, because this one is going to give you 3 over x. If you drop this exponent, it's going to be 3 over x. So as you can see, the numerator will be the same, so but you write it like this. So that's what you're going to have there, guys, from this concept. That's our dy dx there. That's how you're supposed to do it. Any other way there is not quotient rule. This is what you're supposed to do when applying quotient rule, guys. All right, so let's see another part. Where is this question paper? Okay, this part is actually done on question 2. That's what we had, and it's actually 20 marks for that. And we have question 3, where we are given a trig there to simplify. On question 3 we are given a trig to simplify. So take note, guys, whenever you're working with trig, it's all about the quadrants that you're going to use. So there we are given sine minus x, guys. Remember, sine minus x, this is the fourth quadrant, and in the fourth quadrant sine is a negative, so it's going to be minus sine x over sine 180 plus x. Okay, this is 180 plus x, which is the third quadrant. Remember, guys, this is your 180 plus x. All students take calculus, and this is for tan, which means sine is a negative. All right, so sine is a negative in that quadrant, plus 1 over sec x. Remember, sec, guys, is 1 over cos, so this is 1 over cos x times sine x plus 90. Okay, this one we know from our direction that if you are given from our cofunction there, if you are given 90 plus x, 90 plus x is actually in the second quadrant, and in the second quadrant sine is a positive. Remember, from your cofunction, a sine is going to change into a cos. Okay, so it will change into a cos, but it's a positive because sine here it's a positive. So this is going to give us a positive cos x. Okay, then we have got minus tan x, everything over cot x, also cot 90 plus x. Remember, 90 plus x is in the second quadrant, and cot it's 1 over tan, so tan can never be negative, can never be positive here. Tan in the second quadrant is a negative. All right, so this is going to be negative tan x. Remember, cot 90 plus x changes into what? Into tan, like that. All right, but it's going to be negative. So that's what we have, guys. And we have to simplify further. That's minus sine x cancels. That's a 1 here, right? Negative this one is just same like over 1, so this can cancel, which means you are left with 1. So 1 over 1, which is 1, so you're going to have plus 1 here. Negative and negative cancel, which means it's going to be a positive. Tan and tan will cancel, which is 1. Oh guys, that's 1 plus 1 plus 1, which is 3. So that's what you're going to have in this case. So the whole part here is going to give us a 3. So that's what we had, guys. All right, and another part is to solve for theta given an interval from 0 to 360 degrees. There, from 0 to 360, we need to solve for theta given that sine 2 theta is equivalent to 2 cos squared theta, like that. Okay, so far there is nothing that we can do. Maybe we can just change sine. Remember, sine from our double angle is equivalent to 2 sine theta cos theta, from 2 sine a cos a, so it's 2 sine theta cos theta. All right, which is equivalent to 2 cos squared theta, like this. Most of you guys, you make a mistake here when you cancel cos and cos like that. That is wrong. You are supposed to collect these terms to one side of the equation so that at least you can factorize when it is common like that. You don't cancel. All right, so I'm going to start with this on this side. Maybe it can make sense. I don't know, whichever way. 2 cos squared theta, so if I transpose this to this side, it's going to be a minus, so it's minus 2 sine theta cos theta, like this, which is equal to 0. So transpose, do not cancel that cos and cos because it's common. So now, as you can see, cos and cos is common, we can factor it out. Cos theta also 2 is common, so you can factor 2 cos theta, which is going to give us 2 cos squared theta divided by 2 cos theta. 2 and 2 cancel. Cos and cos is going to give us cos theta minus 2 cos theta. We are going to be left with sine theta in this case, which is equivalent to 0. All right, so now it can make sense because we know that from the 0 concept, each part should be equal to 0. So it means either 2 cos theta is going to give us a 0 there, or cos theta minus sine theta must give us a 0 there. So definitely here we have to solve whatever that you're going to have, divide by 2 by 2, which means our cos theta is going to give us a 0 there. Or what can we do here, guys? Because we are left with cos and sine still at the same time. All right, if we are to transpose here, we are going to see that we are going to have something like this. Cos theta is equal to sine theta. Why transposing? Because we have a relationship between cos and sine to say that sine over cos theta is going to give us tan theta. So for us to achieve this, we have to divide by what? By cos theta both sides. So if we divide by cos theta both sides, this is going to give us cos and cos is going to give us 1, which is equal to sine over cos, which is tan theta, like that. All right, so these are two trig that we are now having, two equations that we are now having. This one for cos and this one for tan. Cos theta, which is equivalent to 0, or tan theta, which is equivalent to 100. So also remember the interval that we are given, that our theta is supposed to be from 0 to 360 degrees. This is what we have. All right, so if this is from 0 to 360 degrees, okay, the first one, we can actually use the the trig function for cos, because this is cos 0. It's going to be easier for you to understand from the trig. Remember, the trig for cos is like this. That is the trig for cos, where this is 1 and this is -1 and this is 0 there. We have got 90, 180 there, 270 here, and this is 360 degrees at this point. So as we can see from the graph of y is equal to cos theta, when cos is equal to 0, that is in the x-axis here, that is where theta is, cos is equal to 0 in the x-axis, and at these 2 points, which is at 90 degrees and at 270 degrees, that is where your cos is equal to 0. When we say cos theta is equal to 0, we are simply saying when y is equal to 0, what are the values of x? So x is 90 and 270 degrees. So from here, your theta is going to be 90 degrees, or another one is going to be 270 degrees. That's what you're going to obtain from this one. When cos is a 0, that is at 90 and at 270. All right. But for tan, it's going to be difficult for us to interpret this from the graph. So we are going to use the concept of what? Quadrants, where we are going to take, all students take calculus. So tan is positive because this is +1 in the first quadrant and in the third quadrant. So we are going to find the reference angle from this tan, which is our reference angle. Remember, your reference angle is equivalent to arctan 1, which is 45 degrees. All right, so this is your reference angle. So in the first quadrant, you're going to take your theta to be the reference angle. So our theta there is going to be 45 degrees in the first quadrant. You take the theta is equal to reference angle in the first quadrant. In the third quadrant, remember, your theta is equal to 180 plus the reference angle. So our theta in the third quadrant is going to be 180 plus the reference angle, which is 45 degrees. So this is going to give us 225 degrees. So another theta here is going to be 225 degrees. So guys, these are the possible values of theta from 0 to 360 that we can have: 90 degrees, 270 degrees, 45 degrees, or 225 degrees. These are all the possible values that we can have in that interval. So as you can see, guys, it's a matter of play around with the question that you are given. You have to try by all means to play around that question that you have. All right, then simplify tan 90 plus b, 90 plus b, that is b, not beta. Okay, tan 90 degrees plus b. So remember, guys, tan is same as sine over cos. So this one we can just take it as sine 90 degrees plus b over cos 90 degrees plus b, sine over cos, that is tan. Why choosing these identities? Because we can expand these identities. Remember, guys, sine is going to give us sine a cos, I don't know now, where did I put that formula sheet again, but it's just like this: sine a plus b, which is going to give us sine a cos b, remember, plus cos a sine b, just like that. That is what you have. So this is ab, which is 90 and beta, so it's going to be sine a sine 90 cos beta, just like that. So it's sine 90 degrees cos beta there, cos b, plus now it's cos 90 degrees sine b. All right, over cos. Now for cos is going to change: cos a plus b, it gives you cos sine. So it's cos like this minus sine. So it's cos sine, but it's a negative, right? So it's going to be cos 90 cos b minus, it changes, it's now sine 90 sine b. All right, so this one you can use your calculator, guys. Sine 90, which is going to give you 1 times cos b, so it's going to be 1 times cos b, cos 90, which is actually going to give us a 0. So this is going to give us a 0 there. So there's nothing actually that's going to come out here. Cos 90, again, that's a 0. So it's going to be 0 there, minus sine 90. Remember, I said it's 1. So it's going to be minus sine b, because this is minus 1. So 1 times cos b, this is cos b. This is 0 here. 0 minus sine b, which is minus sine b, just like 0 minus 2, it's minus 2. And we know that cos over sine is cot theta. That is cot b there, but there's a negative, so it's going to be minus cot b. Cos over sine is cot. If it is sine over cos, that is tan, but cos over sine, that is cot. So that's what we had, guys, from this question. That's what we had. Okay, then another part is to show prove that we have to prove that identity, guys. 3.4, need to prove that sine 2x over 1 minus cos 2x is equivalent to cot x. All right, how can we prove? So proving identities, actually, it's a matter of choosing the side that is most complicated, which is this one, the left hand side. There's a lot of things there that we have on the left hand side, so I'm going to choose that side, which is sine 2x over 1 minus cos 2x, like that. This is the side that I'm going to choose. All right, so knowing that from our double angle, sine is equivalent to sine 2x is equivalent to 2 sine x cos x. Remember, sine 2a is 2 sine a cos a, so it's 2 sine x cos x. But for cos 2x now, I'm gonna be stuck because I'm having 3 identities: cos squared x minus sine squared x, 2 cos squared x minus 1 minus 2 sine squared x. So which one am I going to choose? All right, since here I'm having something with sine and cos here, and cot has to do with cos over sine, so which means I have to make sure that my denominator here has to be more of sine. That it can make sense that way. So I'm going to choose the one with sine, this one. Maybe it can make sense, this one. All right, so it's going to be 1 minus that identity of sine, which is 1 minus 2 sine squared x. So you choose the one which is a little bit more of sine, because you know that your answer is going to be cot. All right, so let's do this, guys. 2 sine x cos x over, if we expand this, it's going to be 1 times 1, which is 1 minus 1, like that. Then minus 1 times, which is going to be plus 2 sine squared x. So 1 minus 1, that's a 0, this one. So 0 plus 2 sine squared x, which is just 2 sine squared x, like that. All right, so as we can see, guys, we can cancel here 2 and 2. This is sine x, and this we have got sine squared. So if we cancel here, we are going to be left with sine x, because there are 2 of them. So if we cancel 1, we're going to be left with 1. So it's going to be cos x over sine x, which is actually cot x. So that is the same thing as what we have on the right hand side. So as you can see, guys, that's how you just simply prove this. That's it. That's it. So we have managed to prove that that side and that side, they are equal. All right, anyways, let's see. Determine without the use of a calculator the value of sine. So this one is just same as sine a plus b. Remember, we talked about this identity of sine, which, okay, sine a plus b. Remember, I talked about this, guys. I said it's sine a cos b plus cos a sine a, cos a sine b. All right, so in this case, we are given this as sine pi over 4 plus pi over 6. This is what we are given, guys. All right, sine pi over 4, pi over 6. Okay, and also the other thing, we are given this in radians. So actually pi over 4, pi is just 180, guys, just like 180 divided by 4, which is something like what, 45 degrees. Okay, yeah. Then 180 divided by 6, which is something like 30 degrees. That is 45 and 30. That is what it means. Okay, so okay, let's just expand first. Sine A cos B, which is going to give us, this is your A, this is your B, so it's going to be sine pi over 4 cos B, which is cos pi over 6, plus cos A, which is pi over 4 sine B, which is sine pi over 6. So where are we going to obtain these values? Remember guys, we said pi over 4 is same as 45 degrees and this one is same as 30 degrees. So these are given from sine, so we can go back to our triangles, from those special triangles, and put sense from there. Remember, we're just gonna have our right angle triangle like this. All right, so we had got pi over 4, so pi over 4 is actually 45 degrees, which is pi over 4. So that's pi over 4, pi over 4, and we said pi over 4 is 45 degrees. So remember, the diagram for 45 is supposed to be 1 square root of 2. That is what you're supposed to have. Okay, so here we are given sine pi over 4, which is sine 45, which is square root of 2 over 2. In this case, square root of 2 over 2. This square root of 2 over 2 like this was taken from the adjacent, from the opposite over the hypotenuse like this, 1 over square root of 2. This is the one which gave us square root of 2 over 2. So it simply means this is 1, this is 1. All right, from your 45 degrees. Okay, remember the triangle, guys, from your 45 degrees. The same thing is what happened here. They just want to confuse you. Okay, another one is pi over 6, of which pi over 6 is 30 degrees. Remember I said pi over 6 is 30 degrees. So remember, this is where you have got your 60 degrees here, and this is where you have got your 30 degrees. So this 30 over 30 degrees is your pi over 6 here. So remember, this is 1, and this is 2, and this is a square root of 3 from that triangle. So that is what you're given, sine pi over, which is sine 30. As you can see, sine 30, it's opposite over hypotenuse, is 1 over 2. So those are special triangles that they just gave you in a disguise. All right, so you're just supposed to use special triangles. That is what it means, guys. Just like that, that is what it means. So sine pi over 4, which is pi over 4, remember sine, it's opposite over hypotenuse, 1 over square root of 2. So you're going to have 1 over square root of 2 times cos pi over 6, pi over 6, which is 30. So cos 30 here, cos, remember, it's adjacent over hypotenuse. So adjacent is square root of 3 over hypotenuse, which is 2. Is that so? Square root of 3 over 2. Yeah. Square root of 3 over 2. Like that. All right. These guys, remember, in a simplified division, okay, I'm going to talk about this later on. Okay, let me just leave it. Cos pi over 4, cos pi over 4, which is cos 45, is going to give us the same here, 1 over square root of 2. So it's 1 over square root of 2. I'm going to talk about this later on. Then sine pi over 6, which is sine pi over 6. We're already given this one, which was 1 over 2. This one we are already given. But take note, we said 1 over square root of 2 is the one which was simplified here to give us square root of 2 over 2. So whenever we see 1 over square root of 2, it's square root of 2 over 2 from your sets. All right. So this part here means square root of 2 over 2 over square root of 3 over 2 like this, plus the same thing, 1 over square root of 2 means square root of 2 over 2 times 1 over 2. So you can multiply square root of 2 times square root of 2, which means 2 times, we multiply these numbers under the square root, 2 times 3, which is 6 over 2 times 2, which is 4. Remember, from your laws of sets, you can do that, plus square root of 2 times 1, which is actually square root of 2 over 2 times 2, which is 4. So take note, the denominators here are the same, so you can add just like y over 1 over x plus 2 over x. You can simply add to give you 3 over x. So this is the same. You can combine because the denominators are the same. You just combine the numerators, which is going to give us something like square root of 6 plus square root of 2 over 4. you add these two, so these ones cannot be added. You can't combine from your laws of sets. Remember guys, from n3 that these two cannot combine. You only add when the two are the same, not like this. Okay, so there's nothing that you're going to do there from our laws. All right, so that is what we had, guys. So as you can see, that's how they play around us, guys. Okay, let's see another question, which is question 4. So that's what we had, guys, on question 3. That was 20 marks for that. Draw the graph of y is equal to cot x between -1, 8, 8, 1, 8. So this one, these types of graphs, guys, you're supposed to know them. You are supposed to know how the graph or that one looks like. That one you are supposed to know them. All right, so this is how the graph of cot looks like. So remember, it's an inverse of tan, so it's going to look like this. -90 -180. Remember, we're given from -180 up to 180, so this is 90, 180. So remember, it has a value there at 1, that is what we have only. So this graph actually is going to look like this. At 180, it is going to be your asymptote. There's an asymptote there at -180, which is the same thing also at 180 is an asymptote. Also, the y-axis itself, this one, it's an asymptote at x is equal to 0. That's where we have your asymptotes. So your curve, remember guys, it looks like this, just like this. All right, so remember, this is an asymptote, so it tends to approach this, but it's not going to reach that part. Also, here we have another same thing, just like what that one for tan, but it opposes that one for tan. So like I said, guys, you are supposed to know these ones. How do they actually look like? So this is the graph of y is equal to cot x. All right, that's what we had, guys, from -180 up to 180, just like that. All right, so this one was a little bit pretty direct. Then we are given to draw the graph of y is equivalent to x. This is x, so this is actually the opposite of what we are used to. Remember guys, we are used to this graph as y is equal to, but this time it's x is equal to 2y squared minus 5y minus 3. So just like what we have for the graph of y is equal to, even if it is x is equal to like that, we are going to apply the same thing. So remember, in the x-axis here, y is equal to 0 for the x-intercept. So here y is equal to 0. So when y is equal to 0, then x is going to be -3. When y is equal to 0, x is equal to -3. So which means this graph crosses the x-axis at -3. All right. Then for the y-intercept, remember x is supposed to be equal to 0. So you're supposed to solve the equation 2y squared minus 5y minus 3 is equal to 0. So you can do by factorization, or you can do by the quadratic formula. But if you solve properly here, you're going to have y is equal to 5 plus or minus the square root of minus 5 squared minus 4a, which is 2 times c, which is -3, over 2 times a, which is 2 times 2. All right, so here we are going to obtain two possible values of y, which is 3, or y, which is -1. All right, so these are the y-intercepts. Okay, -half, not -1, but -half. Okay, so these are your y-intercepts. So the x-intercept is at -3, so the value of x, the x-intercept is at -3. The y-intercept, another one, it's at 3, another one at -half. Sorry, this is sorry, that's +3 there, and this one is -half somewhere there. So our graph, since it's for x now, this one is going to approach. We don't know the value of x that we shall have, but it's going to be, this one is going to be your turning point. So if this is your turning point, therefore your shape is going to be like this. All right, this is your turning point for x, so it's going to be like that. So that's your graph there. So take note, guys, we said this is -half here, this is -half, this is -3, and this is 3, not 3. Take note, guys, this is positive 3 at this point. All right, so that's what this graph is going to look like, guys. As you can see, it's going to be open here for the values of x that we shall have, and so on and so on. You should be having two values. And okay, then what is the domain? Remember, the domain, guys, is for the values of x that you drew in question 5. Domain, these are the values of x. So here the domain is going to be from the values of x. As you can see, our values of x, they are operated from -3, but here we do not have any limit for x, so it's going to be up to infinity. As we can see, x is only limited that from -3. We do not have -4, -5, because that is where it curves, but here it's endless, that is infinity. So our x, guys, is not limited from -3 to 0. No, it's limited up to infinity. So x is greater than or equal to -3 because it's greater than here. -2, -1, these values, they are greater than. But what about these values? They are up to infinity. Okay, so it's -3. X is greater than -3, but less than up to infinity, less than or equal to up to infinity. So it simply means that x is greater than or equal to -3, period, where x is an element of what? Of the real numbers, or we can write it as from -3 up to positive infinity, where x is an element of real numbers. This is our domain. Okay, so this one from -half to 3, this is your range. This one is your range. Range affects the values of y, but here we are asked to calculate, to state the domain. So just domain, answer the question. All right, on 4.3, draw the graph of y minus x squared, which is equal to 0. Okay, so how do I end up with this graph of y minus? So this type of a graph actually is going to look like this. Y minus x squared is equal to 0. This is 4.31. So if you just transpose, you're going to see this is y is equal to x squared, guys, and we are used to this one. We know the graph of y is equal to x squared. It's a graph that is symmetrical about the y-axis. That is, it divides the y-axis into two equal parts, because for each and every value of x, you're going to have two possible, for each and every value of x that we have, it's going to give us the same value of y that we have. So it's going to be like this. Here, this one is going to be symmetrical. Actually, this is at 1, it's going to be 1 here, -1 is going to be 1 to 2, it's going to be 4, -2 is going to be 4. So this one, that's how it actually looks like, which is y is equal to x squared, or y minus x squared is equal to 0. So you just write anyway, but that's how this graph is going to look like. Then they are now asking that, is the graph that we have drawn there symmetrical about the x-axis, yes or no? Okay, so this one is just symmetrical. It's symmetrical about what? About the x-axis or about the y-axis? About the y-axis. This is symmetrical about the y-axis, not about the x-axis, but this is about the y-axis. Okay, so see these guys, how they ask these questions. Okay, given that we are given those equations, calculate the values of x, y, and z by using only Cramer's rule. So we need to find the values of x and y there by using the Cramer's rule. So remember, guys, from your Cramer's rule that in order for you to have the value of x, it is going to be the determinant with respect to x over the determinant of constants, the same the determinant of y over the determinant of constants. Your z is going to be determinant with respect to z over the determinant of what? Of constants, just like that, guys. And it's a lot that we're gonna have there. Okay, anyways, let's just put this way and try to have our equation. So as you can see, we've got x, y, and z, but this is not what we have here. We do not have x here. This is 2x minus y minus 4 is equal to 0. We do not have z, so we are supposed to remember our format here for Cramer is supposed to be ax plus by plus cz, which is equal to d, like that. So this is going to be 1 1 1 1. You move on to 2a 2x b2y plus c2z is equal to d2, like that. until the last part. So this is what you're supposed to have: x, y, z, then constant. Okay, so in this case we have got x, we have got y, but we do not have z. So this is what you're going to write it like: 2x minus y. Okay, since we do not have z, so it's going to be 0 z, like that. Then we transpose this minus 4 to this side, is going to be equal to 4. Remember, what we need is the format. That is why we are doing this. All right, this is x, we do not have y, so we are going to have x plus 0y because y is not there. Okay, then this z is on the other side, so when you transpose this 4z to this side, is going to be minus 4z. So it's minus 4z, which is equal to, transpose this 8 to this side, that minus 8 is going to be a positive 8. All right, here this format is fine. X, y, z is fine, so it's 3x plus y there plus 2z, just like how they wrote the last question, like that. That one is in the right format. All right, once you are at this stage, then remember you have to calculate the determinant, guys, with respect to x, with respect to y, with respect to whatever that you're going to have. Okay, so remember that the determinant with respect to x, we are going to take this way. Remember our determinant, guys, in place of x here, you're going to substitute with the constants here. In place of x, suppose here you substitute with 4, 8 minus 5. All right, so it's going to be 4, 8, 5, not minus 5 but 5. All right, then this one 4, y you write as they are. So this is minus 1, 0 and 1. So it's minus 1, 0 and 1 as a column. Minus 1, 0 and 1. You move on to z. This is 0, minus 4 and 2. You take the number and the sign also. 0, minus 4 and 2. So that's what you're going to have there. So you determine the determinant. So remember, the determinant, guys, you just choose any row or any column of your choice that you're going to expand with. All right, so this is what I'm going to do, guys. Remember, you're supposed to have this concept, plus, minus, plus, minus, plus, minus, plus, minus, plus, like that. So each and every sign corresponds to the number inside this. So in this case, I'm going to choose the first row. So I'm going to choose this first row. Remember, this is a row, second row, third row, first column, second column, third column. Okay, so I'm going to expand using the first row. So our determinant is going to be plus 4. So this is 4, so it's going to be plus 4. We find the determinant corresponding to the 4 if we close the column and the row where there is 4 here. As you can see, we are going to be left with 0, minus 4, 1 and 2. So that's 0, minus 4, 1 and 2. Minus times, here there is already a minus here, so it's minus times minus, which is plus 1. All right, you find the determinant. So what you're going to do is to close the row. Is already closed, so you just close this column. So you're going to be left with 8 minus 4, so that's 8 minus 4, 5 and 2, so that's 5 and 2, plus 0 there, so it's plus 0. So whatever that you're going to obtain, this is 0, guys, so there's nothing. But what you're supposed to do is, the row is already closed, so you're going to close this column where there is a 0 here. So you will left with this 2 by 2 matrix, 8 0 5 1. So it's 8 0 5 1, like that. But any number times 0, that's a 0, so there's nothing here. So remember, this you are going to find the determinant, which is the determinant, remember, is the product of the major diagonal minus the product of minor diagonal. So it's this here together minus the product of these two. 0 times 2, which is 0, minus 1 times minus 4, which is minus 4, and this is going to give us 0 plus 4, which is 4. So you're going to have 4 there. So this is going to be times 4 plus 1 times, you do the same, 8 times 2, which is 16. So this is 16 minus 4 times 5, which is minus 20, which is going to give us 36, if I'm not mistaken, guys, plus this one. No matter what you're going to have, that's a 0 there. So 4 times 4, that's 16, plus 36, which is 52. All right, so that's our determinant with respect to x. So you just find this and put it aside, because remember, we have to use this formula later on. So just find it, put it aside. It's useless for now. We move on to, so you have to move on to another part now. Do the same now for y there. So for y, you're going to substitute y this time with constants. So this time it's here in place of this y here. That is where we are going to substitute with constants. So which means the first part is going to remain as it is, 2, 1 and 3, just as it is, 2, 1 and 3. Then the second part, this one, you replace with constants, which is 4, 8 and 5. 4, 8 and 5. Okay, the last part you just take as it is. Remember I said this is 0 minus 4, 2. So this is 0 minus 4, 2. You determine the determinant just like what you did for x, guys. You just do the same, plus, minus, plus. So I'm just going to work with the first row. So there's no need for me to fill in everything. I'm just going to work out with the first row, this one. Okay, so I'm going to take my first row. So which means the determinant here with respect to y. So remember, plus times 2 in the first row. So it's plus times 2, which is plus 2. Then you close the row and the column where there is that 2. So already the row is closed, this one. So you're going to close the column. You're going to remain with 8 minus 4, 5 and 2. Okay, so that's 8 minus 4, 5 and 2, minus times 4, which is minus 4. You close the row and the column where there is that 4. So you're going to be left with 1 minus 4, 3 and 2. So it's 1 minus 4, 3 and 2 plus 0. So it's plus 0. So there's nothing that is going to come out, that there's a 0. So if you close the row and the column, you're going to be left with 1, 8, 3, 5. But there's nothing there. All right, so you do the same, guys. You calculate the determinant. So it's 2, the major diagonal, which is 8 and 2, that's 16. So it's 16 minus 20 there, which is something like what? Okay, 16 minus 20, which is 36. Okay, so that's 36 there. Minus 4 into 1 times 2, this one, you combine this 1 and 2, that's 1 minus this 2. 3 times minus 4, which is minus 12. So it's going to give us 13. 2, this is 2. So it's 2 minus 12, which is 14. All right, yeah. Plus anything that you're going to have here, that's a 0, but it was supposed to be 5 minus 24, whatever that you have, multiply it, put it as 0 there. So this is going to give us the determinant, which is combine these two, which is going to give us a 16. So that's what you're going to have, the determinant with respect to y there. So you put it aside also. So as I said, guys, this is something else. You have to be very, very patient when you are in exam, and you have to be having that energy in exam, because look how it cost us, guys. So we move on to the last part, not the last part, but is the last part according to constants, which is z. So you're going to find the determinant with respect to z. So this time in place of z, that is where you're going to substitute the constants, which means the first part, the second part is going to be as it is, which is 2, 1, 3. So this is 2, 1, 3. The second part as it is, minus 1, 0 and 1. Minus 1, 0 and 1. Then the last part, this one, you substitute the constants, which is these constants, 4, 8 and 5. 4, 8 and 5. So you do the same, guys. You find your determinant. So in this case, I'm going to use again the first row, plus minus. So this is my first row, this is my first row, this one. So I've already closed my first row. So the determinant with respect to z is going to be, remember, the sign multiplies this, so it's plus times 2, which is plus 2. The determinant of, you close the row and column with these 2, already the row is closed, so you're going to be left with 0.85, 0.815. 0.815. You move on to minus 1 and minus 1, so you multiply this sign and this sign, so minus and minus, that's a plus, so it's plus 1 like this. Already you close the column because the row is already closed, so you close this column, which is going to be 1835. 1835. Okay, plus So it's plus times 4, so this one is going to be plus 4. All right, you close the row and the column, which is going to be left with 1 0 3 1. So it's 1 0 3 1, just like that. Okay, so now at this stage, guys, we just need to find our determinants, which is 2 times that's this minus that, so it's 0 minus 8, 0 minus 8, guys, which is minus 8. Okay, plus 1 into, that's 5 minus 24, which is minus 19. 5 minus 24, guys, which is, because remember, it's the product of these two. 1 times 5, which is 5, minus 3 times 8, so it's 5 minus 24, which is minus 19, plus 4 into 1 times 1, which is 1, minus 3 times 0, which is 0, so it's 1 minus 0, which is 1. So it's just 4 like that. So you combine, guys, everything, or you can just use your calculator, but you're going to obtain minus 16, minus 19, plus 4, all right, which is going to give us minus 31. All right, so that is the determinant with respect to z, constant z. We put it aside again. Jesus, this is a lot. All right, but you just have to put it aside. You now work with the determinant according to constants now, with these constants removed. So that is the last part now, which means you take this side as it is now, all those terms as they are. Okay, so it's 2 1 3 2 1 3 minus 1 0 1 minus 1 0 1 0 minus 4 2 0 minus 4 2 as it is. So you calculate the determinant of this. So that's it, guys. Remember, plus, minus, plus, and so on. So I'm going to work with the first row, which is my first row, this one. So that's my determinant is going to be plus times 2, which is plus 2, determinant of, remember, you close the row and the column of 2. So you're going to close like this, which is 0 minus 4 1 and 2. So it's just like a repetition. What is happening here? So it's minus and minus, which is a plus. So it's plus 1 here. You close the row and the column, which means you're going to be left with 1 minus 4 3 and 2, plus 0 here, guys. Here we're not going to waste time. We now know that it's going to give us a 0 here. Whatever that you're going to have, that's a 0 there. All right, so this is it, guys. You calculate your determinant. So it's going to be plus times 2, which is 2. So you're going to remember major diagonal minus this minor diagonal. So it's 0 times 2, which is 0 minus 1 times minus 4, which is minus 4. So which is going to give us plus 4. 0 plus 4, which is 4. All right, which is plus 1 into, you do the same here. This is your major diagonal minus your minor diagonal, this one. So it's 1 times 2, which is actually 2, minus 3 times minus 4, which is minus 12, and this is going to give us 14. Okay, plus 0 there. That's why it says 0. So there's nothing. 2 times 4, which is 8. 8 plus 12, which is 8 plus 14, which is 22. So that's your determinant of constants, which is 22, like that. So we are almost there. So remember, guys, what we are doing, this is Cramer's rule, that your x is going to be the determinant with respect to x over the determinant of constants. So therefore our x is going to be the determinant with respect to x. We are now back to our formulas, to those things that we calculated before, guys. So remember, this was your determinant with respect to x, which was 52. So it's going to be 52 over the determinant of constants, which is this one, which is 22. So it's over 22. You find your x there. Your y is going to be the determinant with respect to y, which gave us 16. This was 16. So it's going to be 16 over the determinant, which is 22. You do the same for z. The determinant for constant z, which is negative 31. So it's going to be negative 31 over 22, just like that. So you simplify, guys, and this is gonna give us 2 2,36 something, 64 if you round off properly here, and y is going to give us 6/22, which is 0,727272 something like that, which is 727. All right, so that's what we have here, and our z is going to be negative 31 divided by 22, which is negative 1,40909. 409 to 3 decimal places. So remember, the degree of accuracy, guys, that's supposed to be 3 decimal. So all in all, guys, that's what we had. The value of x, the value of y, the value of z there, and we have got 10 marks for that. And guys, this is something else. So I don't know the working, the time, and is it worth the 10 marks, or maybe I don't know, but that's what we had, guys. Anyways, let's see the other part that we were given, which is on question 5, to simplify and leave the answer in the a plus jb form, which is the rectangular form. So this is the rectangular format, or the Cartesian form. So it's called the rectangular or the Cartesian form. So remember, this is polar form. We have to combine that in polar form and give us something which is okay, let's just put it this way. This is 4 degrees by 3 into minus 30 degrees, like this. So this one they can write even as cis whatever. So this is 9, so the angle of 60 degrees, like that. All right, so they can even put it this as this one. They can even put as cis, like this. Cis minus 30 degrees is just same as angle, like that. So remember, guys, in polar form, I told you that you have to multiply these two in polar form. When you're multiplying, you multiply these two numbers together. So that's 4 times 3, which is 12. Then you add the angles. So you're going to add 4 plus minus 30 degrees. Remember, guys, the concept R1 theta 1 by R2 theta 2 is going to give us R1 R2 theta 1 plus theta 2. You add the angles. All right, so that's the concept there, which is going to be 9 angle of 60 degrees. So if we add these two, we are going to obtain 4 minus 36, which is actually 4 minus, which is 26. 26, yeah, that's minus 26. So it's going to be 12 angle of minus 26 here. All right, everything over 9 angle of 60 degrees. So here we can actually divide this 4 over 3, which is 12 over 9 here, which is 4 over 3. Okay, angle of, remember, when you are dividing, you subtract the angle. So it's minus 26 degrees minus 60 degrees, which is minus 86 degrees, like that. All right, so what have you done? You have expressed in polar form in a simplified version, but this is not what you asked. The question needs you to convert to the form of a plus jb, which is in Cartesian form. So remember, how do you convert in polar form? Your z, which is equal to r theta, can be written as r cos theta plus rj sine theta in what? In Cartesian form. So this is your r here, this is your theta, so it's going to be 4 over 3 cos this angle. So your z is going to be 4 over 3 cos minus 86. We just write that angle as it is, cos minus 86, okay, plus 4 over 3 sine this one, as you can see. So it's going to be plus 4 over 3j sine minus 86, as like this. It's now in Cartesian form. By that, it's now in Cartesian form. So all you need is to use your calculator. 4 over 3 cos, make sure that your calculator is in degrees this time, in degrees, which is going to give us 0,093028, something like that, which is actually 0,093. All right, here you simplify 4 over 3 sine this. This j cannot be simplified, you just write it later. So 4 over 3 sine minus 86, which is going to give you minus j 1,3308, whatever that you're going to have, which is minus j 1,330. As you can see, this one does not affect, it's just a 0 there. So that is actually the rectangular form for you guys, which is the Cartesian form. If you are given something like this is to express in Cartesian form. All right, so that's what we had. And in this case, this was square root. This was j square root of 2, like this one. It was like this. Let me just write it down here. Our z was equivalent to square root of 2 plus j square root of 2. So the question is to find z bar, which is actually the complex conjugate. Okay, if you are referring to the conjugate, remember the conjugate of a complex number, you introduce a negative, so it's going to be written as z bar, which is square root of 2. You introduce a negative on the imaginary part, this one, so it's minus j square root of 2. So that's the complex conjugate. That's what they just needed there. All right, then change this one to polar form. Now the complex conjugate to polar form, show all the steps. So you need to convert to polar form. So remember, to polar form, all you need when you are converting, you need to have this is your z bar, which is square root of 2 minus j square root of 2, like that. So actually you just need a hint of knowing what it's going to look like. It's going to be like in the third quadrant, where you're going to find the resultant and the angle theta. So the resultant r, remember, is the square root of this will be your a and this is your b. So it's square root of a squared plus b squared, which is a square root of 2 squared plus this b, which is a square root of 2 squared, again with a negative, but that one does not going to affect, because this one is just going to give you 2 plus 2, which is actually square root of 4, which is 2. So the resultant is going to give you 2. Then you calculate the angle, which is theta. Remember, theta is equivalent to arctan b over a, which is opposite over adjacent. So this is your a and this is your b. So it's a minus square root of 2 over square root of 2, which is actually negative 45 degrees. So depending with the what you need, because according to this part it can be negative 45 degrees. So in polar form, our z bar is going to be 2 angle of minus 45 degrees, like that. Or remember, the angle of minus 45 degrees is equal to, this is the angle of minus 45 degrees here, this is minus 45 degrees. This angle is equal to the angle that is going to be taken in another direction from the same point to the same point, which is this one, which is going to be 360 minus 45, which is going to be 315 degrees. So this can be written as 2 angle of 315 degrees. Still, this is in polar form, so that's what we have there. You can write it either way, in that format or whatever that you want, or in another way. Represent that polar form now, which is the complex conjugate on the Argand diagram. Show all the values calculated in question 5.22, which means we need to show the angles and whatever that we had. So actually this is the diagram, but let's just put it aside. So this is 5.23. Let's just put it aside like this. So let's put this aside. Remember, this is your real axis and this is your imaginary axis, the one of j. All right, so, and also the quadrant, we say this is in the fourth quadrant because it was 2 minus 2. So the real is a positive, the imaginary it's a, okay, there's actually no need for us to join this. Okay, so this is your square root of 2 minus square root of 2, like that, and this is your angle here. So you can put it that minus 45 degrees and this is your 2, or you can put this one. So you choose the one to use this one or this one. So this one is going to be 315 degrees. That's your Argand diagram. Remember, Argand diagram, you need to know the quadrant where it is. This is real when real is positive and imaginary is negative. Real is positive, imaginary is negative, is the fourth quadrant. All right, so that's what we just had there. Then the other part was we are given that the price of 2 resistors and 3 capacitors is actually 40 rand. Determine the price of a capacitor and the price of a resistor if the price of 12 resistors and 2 capacitors is 32, and that is actually 4 marks. So this one I'm just gonna give you the equations, then you can solve, guys. Okay, so whenever you're given this type of an equation, remember we just need to know what is going to represent the capacitors and what is going to represent the resistors. So let our resistance in this case be X and the capacitors be Y. So if the capacitors are Y like this, okay, that means the first part they are given that the price of 2 resistors and 3 capacitors. So 2 resistors, which means 2X, 3 capacitors, which means 3 times capacitors, which is Y, so it's 3Y like this. You're supposed to give us a total of 40 rand. So that is the total of 40 rand there. Then when we are working with 12 resistors and 2 capacitors, the total is 32 rand. So it's 12 times 2, 12 times X, okay, plus 2 capacitors, which is 2Y there, is going to give us a total of 32 rand. Alright, so that's your formulated 2 simultaneous equation. So you can actually solve this. I don't know, you're going to use substitution method, elimination method. You use any method of your best, guys, to solve this simultaneous equation. So your X is going to give you 1/2 and the other Y is going to give you 13 if you solve. So this is what is important, the method you can choose. I don't know which method is best, substitution, elimination, elimination by substitution, whatever that is best for you. Okay, so which means X, if it is half, which is the resistor, so each resistor is going to cost 0.50 because this is amount rand, and each capacitor is going to cost 13 rand. So this is amount, guys. So you solve, like I said, I don't know, guys, which method is of your best fit here. I actually do not know the method of your best fit. All right, so maybe you decided to make X to be the subject here. You can make X to be the subject, which is going to be 40 minus 3Y like that. Then you divide by 2 each and every term. So your X is going to be 20 minus 3/2Y like that. So in place of X, we're going to substitute that X, which is 20 minus 3/2Y like that, plus 2Y, which is equal to 32. So that's gonna be 12 times 20, which is 240. Then 12 times negative 3/2, which is going to give us negative 18Y, plus 2Y is equal to 32. Collect like terms here, we're going to have minus 16Y is equal to 240 to that side is going to be 32 minus 240, which is actually negative 208, which we are going to divide by negative 16. By negative 16, so your Y is going to be 13, just like what we had. So if you have this, your X is going to be 20 minus 3/2 times that Y that you obtained, which is 13. That's why you are going to obtain your X as a half. So like I said, I don't know, guys, which method is best for you. So that one you just solve, but after that, this is the amount, therefore you have to write. So I didn't want actually to solve this, but I don't know how I ended up solving it. That's what you're going to have actually at the end. You write the amounts and so forth. Okay, so that's what we had, and the other part now is to make D to be the subject of the formula. On this part we were supposed to make D. So what can we do there? This is K log D minus R over R like that. All right, which is actually equivalent to L. So what you're gonna do there is remember, we can maybe take rid of the K, which is multiplying. We can just remove this. Let's just remove this first and see what's going to happen later on. This is going to give us log D minus R over R like this. Okay, which is L over K. Remember, whenever you're dealing with a log, you are in base 10. So this is actually in base 10, and we know that in base 10, if we are given, not actually in log 10, in base 10, but in any base, if you are given log a base b, which is equal to c like this, it means this a is equivalent to b to the exponent of c. So the a in this case is this part here, that is the one that is representing your a. So what I mean is that d minus r over r from this law is going to be b to the exponent of c, which is b, your base, to the exponent of the answer there. So it's 10 to the exponent of L over K, like that. All right. At least we are at another stage where we can remove the fractions, because this is same as over 1. So you can cross multiply here. So you can cross multiply. That's 1 times d minus r, which is d minus r, which is equivalent to r times this 10, whatever that you're going to have. So it's going to be r times 10 to the exponent of L over K. So this one cannot be separated, just like that. All right. Then we want to make, remember, we want to make d to be the subject. All right. So what can you do? Simply transpose this to the other side of the equation. So d is going to be, if we transpose this, is going to be r there plus this r that was already there, 10 to the exponent of L over K, just like that. So your d is now the subject. There's nothing that you can do. Maybe if you want to just factor out this r, which is common, yes, you can do that, which is going to be 1 plus 10, because if factor out r, you're going to be left with 10 to the exponent of L over K. So d is the subject there. So that's it, guys. That's how they just play around these questions. But then another part, which is actually the last question, to make it a total of 100, guys, is to solve. All right, so you want to solve there, which is actually 5.5, which is 20 into 3 to the exponent of x minus 1, which is equal to 16. So remember, when you're solving this part, it's a matter of which is best. Play around the question. So in this case, 20 has nothing to do with x, so I can actually divide by 20 both sides. All right. So that's 3 to the exponent of x minus 1, which is equal to 16 over 20, which is going to give us 0.8 as a decimal. All right. I want to solve for x, but this x is on the exponent, so definitely I have to introduce the logarithms. So this is going to be ln 3 to the exponent of x minus 1, which is equal to ln 0.8. So remember that the moment you introduce ln, you have to drop this exponent, which is going to be x minus 1 ln 3, which is equivalent to ln 0.8 or whatever that you're going to have. So this is now multiplying, so you can remove this. Instead of multiplying inside, divide by it both sides, so this can actually cancel. So you are left with x minus 1, which is equal to the value that you're going to obtain, which you do not know for the meantime. So just write as log ln 0.8 over ln 3. So remember, I want to solve for x, so I can actually transpose this minus 1 to this side. Is going to be a plus 1. So x is going to be 1 plus whatever that I'm having here, which is ln 0.8 over ln 3, like that. So on your calculator, it's just going to look like this. So that's it, guys. Just transpose this, or you just ln whatever plus 1 is 1 and the same thing, but that's your x, which is going to give you 0.79688. Is that 88 or whatever that you have there? So x is going to be 0.79. This 8 is going to change this into 7. So that is the value of x to 3 decimal places. So guys, as you can see, that's what we had in this case to obtain a total of 100 marks. So guys, that's it. Don't forget to subscribe. Don't forget, guys, to actually subscribe, okay? Because every time there's gonna be light. So that's it, guys, from Maison African Motives, working on mathematics and for question papers and revision, actually working, trying to revise so that we prepare ourselves for the exams which are ahead of time. So we actually have the exams ahead of time. So that's it, guys. Another piece for us to revise before exams. That's it. Till we meet again.